how many of you have used CRD and controllers? Oh, cool. And how many of you have heard of Kubebuilder? Okay, so welcome old friends and new friends. So today, my name is Fan. I'm a software engineer from VMware. So this is my friend, Mengqi, Google engineer. So today we are going to talk about the Kubebuilder. And this is the SDK for extending Kubernetes resources. So this is the agenda. First, we will go over overview of the Kubernetes resources and the CRD. And we will talk about how to extend Kubernetes API and by CRD. And we will introduce the Kubebuilder, of course. This is the framework and SDK. And last, we will run demo to show how to use Kubebuilder. First, we will welcome Mengqi to start.
Thanks. First, let's talk about Kubernetes resources. So core APIs are the APIs that is provided by Kubernetes natively. So they cover the most common aspect, like stateful workload and stateless workloads, load balancer, storage. And the Kubernetes API are very powerful since they are declarative and level-based and asynchronized. So on the right-hand side, it's a common structure of a Kubernetes object. Spec contains the desired state, and the status is the currently observed state. So the user declared the desired state in spec, and the controllers will continuously drive the status towards a spec through a level-based manner. And next, Kubernetes API is awesome and powerful. How can we extend Kubernetes API to support our business logic? So CRD is the recommended approach to achieve this. So when you create a CRD, the API server create a new RESTful resource path at runtime for each version you specified in the CRD. After you creating a CRD, you can add controllers and webhooks to manage your custom resource, just like the core APIs. So the left-hand side is a simple CRD that will be used in the demo later. And the right-hand side is an instance of a customer resource. Next, let's talk about customer resource lifecycle. So when a user create or update a customer resource, first it send the request to the API server, and then API server will send the admission review request to the mutating webhook to do the defaulting. And the webhook will return a response with patches to the API server. The API server then will send another admission review request to the validating webhook for validation. And then the webhook will return the decision to the API server, either admit or reject. Then the API server will persist the object to XCD if admitted. After that, the controller watching on this resource will do the reconciliation. There is another feature called the CRD conversion webhook that will be released in the near future. Let's talk about how to extend the Kubernetes by using CRD. So if we choose to use the from scratch approach, then to support all the steps of the customer resource lifecycle, user need to write the CRD definition, do the code generation, and implement the controller, the webhook, and manage the TLS, and build and publish the image, and deploy them in the cluster. And next, I will hand back to Fan to let him have a deep dive into how to implement, how difficult it is to implement a controller.
Thank you, Mengqi. So, first, first, let's look at the general workflow in the controller built from scratch. So controller is an infinite loop working on the objects in the cluster and performing a reconciliation on the objects. Controllers need a mechanism to look up the particular objects from the API server and retrieve them into a local cache for better performance. So this mechanism is called informer. Normally, this is shared by many controllers. So it won't trigger handling directly, but dispatch the object to controller and let it take over. Controllers has to provide the event handler functions to informer to call back based on the changes of the objects. So event handler increase the objects key to the work key of the controller of the customer controller. So the work key is used for holding the object keys, and the controller has a working loop to process the keys from the work key and use the indexer to retrieve the objects. So and then the controller performs the reconciliation logic to align the current status towards the desired status. So we can see from the left side, this is a basic stack you have to be familiar with to building up a controller from scratch. So on the top, this one is a main entry point where you can start your controller. The API type is very important. Where you can define your CRDs, and you have to register your versioned kind APIs into runtime scheme for serialization. So thanks to the Kubernetes community, we have a very powerful tool like ClientGo. ClientGo provides a tool cache library for building local cache, informer, indexer, many kinds of queries, etc. Code generator tools can help you with the versionized client sets, informers, listers, and deep copy functions. Deep copy functions requires after 1.8 version of Kubernetes. And then a user has to write a code to facilitate the bunch of the stuff we talked before. The last important part is to implement the reconciliation logic in the controller. So for many users, we don't need so much stack. Especially we don't need to write the stacks one by one. A user usually want because it is a steep learning curve. For some use cases, user just need to write a controller very simple. So we can, oops. Okay, yeah. So, so from the stack, we can see there are many toys. So Kubebuilder is designed to scaffold this work and provide common foundations for libraries and the framework, building higher level abstraction. Basically, the Kubebuilder optimizes the full stack by 3 parts: scaffolding projects and APIs, controller tools, and controller runtime. So user only need to focus on the API implementation of the API types and the reconciliation logic. So this diagram shows a high-level relationship between these parts. So as a binary, the Kubebuilder can be run from the command line. This is a command line tool to initialize the project and scaffold it with boilerplates and basic structures, including the hierarchy of APIs, controllers, webhooks, and the entry point of controllers manager, which is a wrapper of the controllers and the webhooks. Dockerfiles is also provided. Dockerfiles is for build and publish the image. The Makefile is used to performing some operations like build, test, and deploy to the cluster. The scaffolded project has dependencies on the controller tools and the controller runtime. Basically, all the functionalities are defined in the two components. You can implement your business logic in the scaffolded project, leveraging the library of a controller runtime. So this diagram shows the end-to-end sequence of running Kubebuilder from the command line. So Kubebuilder takes the command line options like domain to initialize the project and scaffold it. User decided the vendor dependencies, create a version kind APIs, controllers, and webhooks individually, and implement the business logic only in the colorful blocks. So in terms of the controller tools, the controller tools provide a binary, and Go libraries help you work with the code generation and the manifest generation. So at the current stage, the Go work tools process API files and generated deep copy functions for API objects. So, it generates the manifest and documents. The controller tool highly uses the annotations mechanism to facilitate the CRD features. With the Kubebuilder, in the future, the Kubebuilder can support more features by the annotation. So the binary controller gen is also provided for the same purpose. Okay, so this is the important part, is the controller runtime. So controller runtime provides a higher level abstraction for libraries and the framework to implement the control pattern. The controllers have to be added to the controller manager, which provides a shared dependencies like local cache, runtime scheme, REST config, and the REST client. The common, there is a common control pattern. It's abstracted to a series of interfaces. For example, the reconciliation function of the controller can be extracted to a reconciler interface, which takes the request and request interface and returns the result interface and error. The request contains the unique information to identify the Kubernetes resources or CRD. The requests are included in the work queue instead of object keys. So that's the difference with from scratch approach. So all CRD events and the external operations like webhook, pullbacks are abstracted to the source. Controllers have a watch function. The watch function takes the source as parameter as arguments. The source is processed by the event handler to increase the request. The watch function also triggers the reconciler. So we don't have time to deep dive into the controller runtime code base and the use cases due to there are many contents there. So here I just want to say there are so much work have been done to provide the convenience to the user in the controller runtime. If you wanted to know about this high-level abstraction, Solid Ross and Philip Witchwalk will give us a talk in the coming KubeCon Seattle in this December. So this diagram shows major interactive points in controller runtime that you may know. This, as I said, manager is a wrapper. So this is a start point to create a controller. User has to implement a reconcile interface. the controller needs to be added back to manager and started by the manager. So similarly, a webhook server is created and added back to the manager as well. So user has to implement the handler interface. So we welcome Mengqi to give us a demo.
Thank you, Fan. So in this demo, we are going to use Kubebuilder to scaffold a new project, and then use it to scaffold a CRD API and a controller and a webhook. And after that, we will fill in some business logic, and then we will build the image and deploy in the Minikube cluster to test out and verify things works correctly. So due to the networking issue, that I cannot start a Minikube cluster. So the live demo have to fall back to a user recording. So first, let's start with scaffolding a new project structure by running Kubebuilder init. So it will generate a basic structure, including Docker file, make file, entry point for the manager, and then next, we will scaffold a CRD API and with a controller by running Kubebuilder create API. So we create a CRD with a group equals example version v1 alpha 1, and the kind is bounded deployment. And the next step, I will scaffold a webhook by running Kubebuilder webhook command, and which will react on create and update options. And it is a mutating webhook. And the next step, I will run make. So make will do the code generation and the Go format and the Go event. And it will also run the Go test to ensure everything, all the tests are passing before build the binary. And in the end, it build the binary. And the next, let's commit the generated change. Next step, let's add some business logic by applying a patch. And then let's look at what has been added. So you can see that in this text.go, we add a field called a replica, which is integer. And the resource is called the bounded deployment. This is a spec. And next, let's look at, so in the controller file, we also add some business logic. So what it does is it will create a deployment which will have the same replica number as the replica field in the bounded deployment. And the next, let's modify the handler function in the webhook. So what it does is it ensures that in the bounded deployment object, the replica field is always smaller or equal to 2. And next, let's commit the business logic, and then we run make again. So each time you change the types.go or the annotation or the controller, anything, you need to rerun the make to generate the code. So next, let's see what has been generated, updated. So here we can see that the CRD validation schema has been updated. This is for the replica field. And also down here, the deep copy, generated deep copy code has been updated. Next, let's apply some patches for the demo purpose. And next, let's build the Docker image by running make docker build. So what it does is first do the same thing as running make. So it generates code and ensure the test is passing. And then it will use Docker to build the image. Next, let's run make deploy to deploy the controller manager webhook into the cluster, and also along with the correct RBAC rules for the manager. And we can see that the CRD have been created, and also with some other resources like cluster role binding, and the manager and the service. Next, let's get the CRD. By run kubectl get CRD, we can see that bounded deployment has been created. And the next step, we have a sample instance of bounded deployment with a replica equals to 10. Next step, we apply this instance of bounded deployment. So it's created, and the next step, we verify the controller and the webhooks works correctly. So if things work correctly, when we create the bounded deployment with replica equals 10, first the mutating webhook will modify the replica from 10 to 2. And then the controller watching bounded deployment will create another deployment with the same replica. So let's verify by using a kubectl get a deployment, and we grab the replica field. It should be 2. We can see that the replica field is 2, so the things works perfectly. Next, let's do a quick recap after the demo. Oh, okay. Okay, let's do a quick recap after the demo. So from the demo, we can see that first, Kubebuilder is easy to use. It scaffolds the project controller webhook by simply run a few Kubebuilder commands. And the second, it requires minimum operations. So mostly, you only need to fill in your business logic. It's easy and fast. And the third, it streamlines the workflow. So the recommended workflow is captured in the make file. You can simply do that by running make with different targets. And then there are some resources. First is a Kubebuilder repo. It's under Kubernetes 6, and then the Slack channel, and then there's a workshop from Philip Wartalk, which you can try offline. And lastly, contributions are welcomed. Thank you. And next is the QA session. Anyone has a question?
Thank you for your presentation. I have a question. How can the sub-resources use Kubebuilder?
You are asking how Kubebuilder handling sub-resources?
Yes, like log or exec.
The sub-resource, Kubebuilder currently supports the sub-resource feature of the CRD, so you can use the annotation like the double slash. So it's a normal annotation schema in the Kubebuilder. So like double slash Kubebuilder and with sub-resource and with you have to specify the spec and the status. So yeah, so use the annotation to do that. So yeah, so the sub-resources will be generated in the CRD.
Thank you.
I have something to add. That so in the controller runtime repo, you can find that we have client to support sub-resources. So even use Kubebuilder, it will like a generated sub-resource, generated code from using the controller runtime. You can check it out.
Actually, I have two questions. First is how to generate open the API schema so that I can generate clients for other languages such as Java. My second question is how to we migrate from previous API server builder generated code to the Kubebuilder.
You were asking, okay, the first question you were asking how to generate the open API schema, right?
Yeah.
So the Kubebuilder currently supports the open schema v3, but only a subset of that. So using the annotation as well. So we have a document in the repo saying how to use you can use the annotation to validate the schema. So these ones will be generated in the CRD YAML file.
My second question is how to generate code from API server builder to Kubebuilder.
This question, I think that the API server, the API server builder is it's a deprecated project, yeah. And I'm not super sure we have a migration document for this thing.
No,
but I think the most easy way is that you use a Kubebuilder to generate a project, and you copy your business logic to the new project, and that should work, I guess.
Yeah, the general thinking is to make it lightweight. So lightweighted, so use a Kubebuilder to bootstrap a very thin layer of the controllers. So we don't want to involve the many dependencies of other components. So migration may be, we can think about that in the backlogs.
It seems we are running out of time, so we are happy to take questions offline. Thank you all.
Thank you.
谢谢。